All right, guys, this is a calculus video on 7.1, which is on area. Chapter 7 goes off of the application of integrals. You're done learning all your integral rules, so now we're going to see how it applies. Personal opinion, this lesson, the calculus is extremely easy. You've been doing the calculus for a while already. What's difficult is the interpretation of the equations they give you and how to work out the algebra or graphing behind it, okay? I will give you two methods always. I'll give you the visual with the graph and the algebraic, but you are going to need a little bit of both to help you solve this. So back in chapter 4, we had talked about that the reason we need to learn integration is because integration gives you total amounts and areas under the curve. So we have seen before the area under the curve, and we would just do the integral of that function. Now we want to enclose a space and find the area of a region. Okay, so if you just look at this image, let's talk about concept for a second. If I close off this region with these two graphs, F is the top one and G is a parabola underneath, okay? If I find the area underneath F, I'll get all this green, okay? If I find the area underneath G, I get all of this red, okay? Now, hopefully it can make some logic to you that if I do the green minus the red, I get left over with the section that was bounded in between the two, okay? So for that reason, whenever you're doing area under a curve, it is the area of the integral of the top function minus the bottom function. So here, based on what they were labeled, I put F minus G. But what I'd like you to memorize is area is integral of top minus bottom, okay? Now, these two parabolas do get closed off where they intersect, where they meet, okay? So on a level easy question, they will give you where they close off. On a level medium and up, they will force you to find A and B on your own. And the way I do that is I find the points of intersection, which I do that by setting the two equations, F and G, equal to each other, and then I solve for X, okay? So the majority of their questions are top minus bottom. When these equations get a little more complicated, what I would consider level hard, is when the functions don't work top to bottom. Okay? So look at this image down below. Top minus bottom, the reason why I picked top is because top has the greater values. So if I'm reading a graph left to right, who would have the greater value, a left or the right? The right side. So for that reason, it works the same way, but it is right minus left. Okay? Now notice that these two equations are different because this one says dx and this one is dy. So when I read equations top to bottom, okay, look at this little box here. My function will read y equals, and it'll have a function with x's. So like y equals x squared or square root of x and things like that. And your a's and b's here will be x values, okay? When I work side to side, okay, this is considered more of the level difficult question. Notice that my intersection points are different y values. So my a's and b's will be y values, and I will have to myself change the function to be x equals a function in terms of y's, which takes a quick moment of algebra. The hard part is knowing when to do that, okay? All right, so on slide 8, we have our first example. So it says, find the area of the region bounded. When you have a test with all calculus mixed, like, for example, those of you who would take the AP test, you'd see area bounded. You know that this is this kind of problem, okay? Now, they give me that it's bounded by f of x, g of x, and they give me the two x points. This here is your A and B. You'll see it a little better when you draw it, but this is considered a super level easy because you don't even have to take that step of solving for A and B. So if I check out my graph, what is a graph of x squared? Parabola facing up, and what does a plus 2 do? Right, it makes it move up 2. So 1, 2, and I have a parabola. Okay, what is the graph of negative x? It's a linear function with a negative slope. Do you already see who top and bottom is? Okay. Now they want you to do this from 0 to 1. So 0 would be right here. And let's say 1 is right here. So with a different color, you can kind of make your little area that got closed off. Do you guys see it there? The little section that got closed off? So the top function will close off the top. The bottom function, g of x, closed off the bottom. And then they said x equals 0, which is a vertical line at 0. And then x equals 1 is a vertical line at 1. So, I mean, it'll end up being like, it closes it there and then here. You see the shape how it closes off? All right, so if you know me at this point, as I'm recording, I'm pregnant, and my students have just analyzed that my pregnancy brain has failed me. I drew a positive x instead of a negative. So I'm going to pause the video and fix that graph really quick, okay? All right, so here's our graph fixed. I apologize for that. It was a negative slope, which just made my area that I shaded go a little further down, okay? So remember, we did not have to solve for our a and b. They were given to us. So we would be writing the integral from 0 to 1. You can visually see on top with the graph that the parabola is on top. So in this case, I would be doing f, the parabola, minus g. If I did not draw the graphs, my job would be to figure out a point in between 0 and 1 to plug into both equations, and whichever equation gave me the higher y value would be on top. So in between 0 and 1 would be 1/2. So I would say f of 1/2, which gives me half squared plus 2, which is 1/4 plus 2, which is 2 1/4. Okay? And then I would do g of 1/2, which just gives me negative 1/2. So I'm comparing 2 1/4 and a negative 1/2. Which function gave me a higher value in between 0 and 1? F. So that's how you know without the graph who is top and who is bottom. Okay? So whether you drew the graph or you chose to use the algebra, you can still see that the function f, which is x squared plus 2, is first minus g of x, which is the bottom. Now, I encourage you to put parentheses. I know this is a much easier question, but it is going to be useful when the equations start getting longer, okay? Because once you figure this part out, who's on top, who's on bottom, what's your a, what's your b, the rest is pretty easy. So I have the integral from 0 to 1. Clean this function up, okay? So I'm just going to make these two negatives here become a positive. And then I'm going to write it in order. So I have x squared plus 2 plus x. To make my life a little easier, I'm going to write them in order. X squared plus x plus 2. And now use your reverse power rule to do the antiderivative. I get a third x cubed plus a half x squared plus 2x. And then all I have left is my f of b minus f of a. Now, don't get too excited when I say this, but for this chapter, I'm going to allow you to leave it 100% messy right here at the f of b minus f of a. Oh, you're right. I'm so sorry. I forgot an x here. There we go. All right, we're continuing with a question on slide 10. It says, find the area of the region bounded, again, your key words to let you know what you're doing, of f of x and g of x, okay? This question did not give us a boundary on the sides. They didn't give us more points. So we are going to have to find the a and b for this question. So if you like graphing, I'm going to go through both again. 2 minus x squared. What is a negative x squared graph? Parabola facing down. And this positive 2? It went up 2. Good. So 1, 2. And I have a parabola facing downward. Okay? Don't always trust your drawings. All right. And how about the graph of g of x, which is just x? Linear, positive. Let's see if I can mess this one up like last time. Okay. So it should be easy visually to see where this closes off. Okay. Now our job next is going to be to find out where these 2 points of intersection land with respect to x. Okay. So my job to find A and B is to set f and g equal to each other. So I'm going to say 2 minus x squared equals x. I need to get everything on one side. So I'm going to move the x squared over with the x and then subtract the 2. And what I get left with on the other side is just a 0. I can put that on whichever side makes me happy. Okay? And now to solve for the x's here, I do have to factor. Okay? So I'm factoring into 2 binomials. And I'm looking for 2 numbers that multiply to give me a negative 2, but combine to give me a positive 1. Good. The numbers are 1 and 2. And then remember, if you need your answer to be positive, you want your bigger number to carry that same sign. Okay? And now we get that x equals 1 and negative 2. So we just found out that this right here is negative 2 and this is 1. So my a is the smaller number, which is from negative 2. And then my b is my positive number, which is 1. So I so far know that my integral is going to read from negative 2 to 1. Now, if you do not like the graphing method, okay, you have to figure out who's top and bottom. So you would find the a and b first, okay? What's an easy number? Easiest number to use in between negative 2 and 1? 0. So I say f of 0 would be 2 minus 0 squared, and that gives me 2. And then g of 0 would just be plugging 0 into x, which is 0. Who has the bigger value? F. So f is on top and g is on bottom. Okay? So top, which is f, is 2 minus x squared minus bottom g, which is just x. And again, I know it seems silly to be putting parentheses right now, but I want you to get into the habit because when these equations get bigger, you're going to need them, okay? So next step is to clean the inside. I have a negative x squared. This will be a negative x and then a positive 2. Antiderivative. Nice, guys. Okay. Now, don't be afraid of a long answer, okay? Here I have the 1 being plugged in. Minus the same function with the negative 2 being plugged in. Now, as long as you are super careful with your parentheses, You are done at that point. So on to the question on slide 11. Sine and cosine intersect infinite amount of times, okay? With bounded regions of equal area. So every time they intersect, they're going to make this little shape. That shape will be equal every time it makes it. Find the area of one of those regions. So graphically, let me refresh your memory on what this looks like, okay? Sine goes over, then under, and we have 5 points on a trig graph. And then cosine starts at the top, goes under, and then comes back up. Okay? So what we are trying to find is this right here. Okay? That's the area that we're trying to find. So when you draw the graph visually, who's on top? Sine. You see it? How the blue one, which is sine, is on top? So just a color code, you know, sine was blue and cosine was green. Okay? So now I need to figure out where they intersect. Okay? So I need to set sine of x equal to cosine of x. Now in my class, we memorize that unit circle like the back of our hand. And if you want to think about what spots on the unit circle do sine and cosine have the exact same value in the ordered pair, you think of the ordered pairs that have the radical 2 over 2's. Now, in 2 of the 4 scenarios that happens, they have the exact same sign. In quadrant 1, we have pi over 4, which the ordered pair is radical 2 over 2, which that's my cosine, and radical 2 over 2, which is my sine. So this is the first time that they intersect. Now the second time happens in quadrant 3, and they're both negative. Whoops. And in the third quadrant, it's still an over 4, but the numerator is 1 more than the denominator. So this right here is 5 pi over 4, which gives me my A to B. Okay? Now, if you do not like graphing, your job, once you find your A and B, is to figure out who's on top. You can plug something in, like we've been doing in the past few questions, or you can think to yourself, in between these quadrants, in quadrant 1 and quadrant 3, who is bigger, sine or cosine? Remember that sines, just think of quadrant 2. Do you agree that quadrant 2 is in between quadrant 1 and 3? In quadrant 2, all of my sines are positive, and all of my cosines are. So, in quadrant 2, we have negative comma positive, which means cosines are negative and sines are positive. So who is the top? Who's bigger, a positive or a negative? A positive. So that means sine is on top and cosine, the negative, is on the bottom. Okay? So you can see visually and through our unit circle that sine is on top. So I am writing sine of x minus the bottom, which is cosine of x. Okay? Now, the nice thing about this question is that there isn't much to clean on the inside, so I can go straight to the antiderivative. Antiderivative of sine is, I heard it, negative cosine. Don't forget that negative. Minus, what is the antiderivative of cosine? Good, a positive sign. And I go from pi over 4 to 5 pi over 4. Okay? If you would like to factor out a negative and deal with the negatives at the end, you can do that. You don't have to. So now I'm just doing the last part of my integral, which is f of b minus f of a. All right, so am I done at this point? No. So I have been telling you that you can stop at f of b minus f of a, but if you're taking the AP test, they do not give you credit unless you finish the trigonometry. Okay? So the nice thing is we kind of even wrote ourselves a side note over here as to what the answers of those cosines and sines are at 5 pi over 4 and pi over 4. So we can say that negative, and then cosine of 5 pi over 4 is a negative radical 2 over 2, minus sine of 5 pi over 4 is negative radical 2 over 2. Now minus, over here I have again a negative cosine of pi over 4 is positive radical 2 over 2, minus, and then sine is also radical 2 over 2. Now you can stop. Okay?